Assalamu alaikum dear students. How are you all? I hope you all are fine by the grace of Almighty Allah. Welcome back to Higher Mathematics class, chapter 5, lecture 1. In this class, I am going to discuss about quadratic equation of one variable and their solutions. Look at the screen. There is an equation of second degree of the variable x with leading coefficient a, constant term c, and coefficient of x is b here. This is the standard form of quadratic equation. Okay, we have already solved this type of equation in standard 8 and general math of standard 9 using Middleton factor. But for some of values of a, b, and c, this expression cannot be factorized. That's why we cannot find the roots of this equation easily by using Middleton factor. That's why today we are going to establish an important formula to find the roots of every quadratic equation. For this, first multiplying both sides by a, we get a squared x squared plus abx plus ac is equal to 0. We have to make this expression as a whole square form. That's why we add b square by 4 and minus b square by 4 to balance the equation. Now we get x plus b by 2 whole square is equal to b square by 4 minus ac, and calculating right side we get 4 as LCM and b square minus 4ac. Okay, now applying square root on both sides we get plus minus root over of b square minus 4ac and square root of 4 is equal to 2. Okay, now changing side of b by 2 we get x is equal to minus b by 2 plus minus root over of b square minus 4ac divided by 2, and adding this 2 we get 2 as LCM and both here denominators are same, that's why numerator will be added or subtracted. Minus b plus minus root over of b square minus 4ac, and therefore x is equal to minus b plus minus root over of b square minus 4ac divided by twice a. Now in an equation, roots of the equation is equal to the number of the degree of the equation. In a quadratic equation, degree of the equation is 2, therefore we get the roots of the equation 2. Here plus minus, if we take plus here then we get first root, if we take minus here then we get second root. Therefore two values or two roots of x are x1 is equal to minus b plus root over of b square minus 4ac divided by twice a, and x2 minus b minus root over of b square minus 4ac divided by twice a. We get two values of x. These two are called roots of the equation. Okay, and nature of the roots are depending on this expression b square minus 4ac. That's why this b square minus 4ac is known as discriminant. This b square minus 4ac is called discriminant of the equation and it's denoted by capital D. Okay, discriminant means নিশ্চয়ক, এটাই নিশ্চিত করতে পারে যে ইকুয়েশনের রুটস গুলোর নেচার কেমন হবে, এর জন্য একে বলা হয় নিশ্চয়ক অর ডিসক্রিমিনেন্ট। ওকে, আচ্ছা চলো আমরা দেখি যে এটা কিভাবে নিশ্চিত করছে রুটগুলোর নেচার কেমন হবে। We get two roots x1 and x2, and discriminants of the equation is b square minus 4ac. Variables and nature of the roots of a quadratic equation depending on the condition of the discriminant. First condition, if d is equal to 0, that means if discriminant is equal to 0, then roots of the equation are real and equal. That means if d is equal to 0, then this part is 0, this part is 0. Then roots of First root is minus b by twice a, second root also minus b by twice a. Therefore, we get roots of the equation are real and equal. Okay. Second condition, if d greater than 0, then roots of the equation are real and unequal. If d greater than 0, then square root of something have some value. Okay. Therefore, minus b plus something value and minus b minus something value are different. Therefore, roots of the equation are different. Okay. Unequal. Real and unequal. Okay. If d greater than 0 and d is not a perfect square number. If d greater than 0 and d is not a perfect square number. Non-perfect square number are 2, 3, 5, 6, 7, etc. And we know square root of non-perfect square number is an irrational number. Okay. Therefore, if we add irrational number to some rational number, then we get irrational number. Okay. Then roots of the equation will be irrational. Okay. If d is not a perfect square number and d greater than 0, then roots of the equation are unequal and irrational number. Okay, clear? If d greater than 0 and d is a perfect square number, if d greater than 0 and d is a perfect square number, that means 4, 9, 16, 25, etc. If here b square minus 4ac is equal to 4, then square root of 4 is equal to 2. Then we get a rational number. And we know sum of the two rational number is a rational number. And if we divide a rational number by another rational number, then we get another rational number. Therefore, if b square minus 4ac is a perfect square number, therefore roots of the equation are real, unequal, and rational number. Okay, clear? If d less than 0, if d less than 0, that means minus something, minus 1, minus 2, minus 3, etc. Okay, less than 0, negative. এবং আমরা জানি যে স্কয়ার রুটের মধ্যে যদি নেগেটিভ চলে আসে তাহলে সেটা কি হয়ে থাকে না, রিয়েল থাকে না, সেটা হয়ে যায় ইমাজিনারি নাম্বার। তাহলে স্কয়ার রুট অফ -1, -2 এগুলো কি হয়ে যাবে, ইমাজিনারি নাম্বার হয়ে যাবে। ওকে, এবং এখানে একটা রিয়েল পার্ট আছে -b আর স্কয়ার রুট অফ মাইনাস সামথিং, দ্যাট মিন্স ইমাজিনারি পার্ট। তাহলে রিয়েল পার্ট এবং ইমাজিনারি পার্ট সম্বলিত যে নাম্বারটা থাকে তাকে আমরা কমপ্লেক্স নাম্বার বলে থাকি। তাহলে রুটস গুলো কেমন হবে, কমপ্লেক্স নাম্বার হবে। ওকে, রিয়েল নাম্বার হবে না, আনরিয়েল হবে, দ্যাট মিন্স কমপ্লেক্স হবে। তাহলে রুট গুলো কেমন হবে, কমপ্লেক্স হবে। এবং তোমাদের এটা জেনে রাখতে হবে যে কমপ্লেক্স রুট কখনো একা একা আসে না, কমপ্লেক্স আসে কনজুগেট, মানে জোড়া আকারে আসে। যদি কোনো একটা ইকুয়েশনের ডিগ্রি হয় 3, তাহলে রুট কয়টা থাকবে, 3 থাকবে। ডিগ্রি 4 হলে রুট কয়টা থাকবে, 4। এর মধ্যে যদি একটা রুট কমপ্লেক্স থাকে, তাহলে অবশ্যই জানবা যে আরো একটা রুট আছে যেটা তার কনজুগেট নাম্বার, সেটাও কমপ্লেক্স। যদি মনে করো কোন একটা ইকুয়েশনের একটা রুট আছে a প্লাস ib, তাহলে এটা ইনশিওর করে যে ওই ইকুয়েশনের আরো একটা রুট আছে a মাইনাস ib। ওকে, কমপ্লেক্স নাম্বার কি থাকে, কনজুগেট আকারে থাকে, জোড়া জোড়ায় থাকে। ওকে, তাহলে if d less than 0, then we get the roots of the equation are not real. In this case, two roots are always conjugate complex to each other. Okay, here quadratic equation, that's why two roots. If there is a third degree equation or fourth degree equation, then there we get 3 roots, 4 roots. Okay, among them, if one is complex number, then obviously we get another one, another complex number which is conjugate to the previous one, and conjugate number of a plus ib is a minus ib. Okay, now let's solve some problem of this chapter. Problem 1 of exercise 5.1. Use formula to solve the following equation. Given equation is an quadratic equation. Solution given that. Now comparing the equation with the standard quadratic equation. Here is standard quadratic equation ax square plus bx plus c is equal to 0. We get coefficient of x coefficient of x square is equal to a here and here 2. So a is equal to 2. Coefficient of x is here b and here 9. So b is equal to 9 and constant term c. So c is equal to 9 here. Okay. Therefore, the solution x is equal to minus b plus minus root over of b square minus 4ac, and putting the values of a, b, c, we get this, and calculating we get this. Now, two values of x are, first one x1 is equal to minus 9 plus 3 divided by 4, then you get minus 3 by 2, and x2 is equal to minus 9 minus 3 by 4, then you get minus 3. Clear? Another problem, problem 9 of exercise 5.1. Given that 7x minus 2 minus 3x squared is equal to 0, and comparing with the standard form of quadratic equation, we get a is equal to minus 3. Here coefficient of x squared is minus 3, so a is equal to minus 3, and coefficient of x is 7, so b is equal to 7, and constant term is minus 2, therefore c is equal to minus 2. Now putting the values of a, b, c in this equation, you get this, and calculating this, you get this. And two values of x are, x1 is equal to minus 7 plus 5 divided by minus 6, and solving this you get 1 by 3, and x2 is equal to minus 7 minus 5 divided by minus 6, that means is equal to 2. Clear? I hope it is. Now we can solve all the math of exercise 5.1. So do all the maths of exercise 5.1 within 3 days and submit in your group. Thank you.